Hey AP Chemistry, I first wanted to have a very brief video on units and fractions, and I'm hoping that this video is helpful for the rest of the semester with how we derive units from a chemical equation or just like a mathematical equation, and what we do when units are in fractions or what we do with fractions. So first, let's say I'm looking for the second order rate constant units. Okay, so if I want to write a reaction or a rate law that's second order, simply I'll just do rate is equal to K concentration of A squared, and we know that that 2 means second order. Now my rate constant is right here in K, and I want to find what are the units for this K. Well, if I rearrange this equation and solve for K, I will get rate over A squared is equal to K. Now, how did I do that? This has to do with algebra. So just as like an aside, if I had like 50 equals x times 20, right? So like let's say 50 was my rate and my A squared was my 20. If I wanted to solve for x, what do? I divide both sides by 20. And I get 50 over 20 equals x. Well, this is algebra. So if you need some help on algebra or rearranging equations, let me know if I need to post another video or we have some practice with doing that. But now let's say I'm over here and I want to find the units for this K. Well, my rate is always in units of molarity per second. And then remember that molarity is equal to moles over liters. So technically, this rate could also be moles over liters times second. These mean the same thing. Okay? And then my A, remember this is brackets, this is concentration. So concentration is in molarity, which we just said is moles over liter. But don't forget that this is squared. So this technically means molarity squared. And if I squared my molarity, that means I have moles squared over liters squared. And so if I want to try and put all of this together, I'm going to put the rate. Let me just do molarity first. Let me just make it simple and have one letter at a time. I'm going to write this as molarity over second. Right? I'm going to put parentheses, molarity over second, and then my concentration squared is my molarity squared. Okay? So let me move up a little bit. All right, so now I have, now I have molarity over second divided by molarity squared. Now I'm not sure if you know what to do when you have a fraction in the numerator and there's a denominator, like, so this is my whole thing is my fraction. This whole thing is technically my numerator. And this bottom is technically my denominator. I don't know if you know what to do at this point with fractions. That's why this is also titled fractions. Technically, if I have a fraction in my numerator, and my numerator has a denominator, and I have another numerator in my numerator, this denominator just goes to the bottom. So technically, if I have this fraction and I multiplied by, if I have this fraction and I divide by a number, what I'm doing is just taking my denominator and putting it into the denominator. I'll show that later with numbers. And so this becomes molarity over seconds times molarity squared. Okay? So for right now, if you know how to do this, my denominator of my numerator just goes into the denominator. I combine denominators. This is kind of like, another way of writing this, and what I was trying to say is, instead of this being like molarity divided by seconds divided by m squared, this is technically like molarity per second times 1 over m squared, right? Because if I didn't have this numerator and I just had m squared in my denominator, this m squared in my denominator would just look like that. And so I would arrive at molarity over seconds times molarity squared. Now, I don't know if you remember this, but what would I do if I had like x cubed over x squared? What can I simplify that to becoming? What do I do with my exponents in a fraction like this? What you should do is you subtract those exponents. So 3 minus 2 technically becomes x to the first, and then I have no x in the denominator. I'm going to do the same thing here. I put a 1 here. Molarity raised to the first or molarity, it's the same thing. If I have 1 molarity in the bottom and I have if I have 1 molarity in the top and 2 in the bottom, this could cancel out and this cancels out, and I'm left with 1. I could do 1 minus 2 and I get -1, and -1 means it's in the denominator. So technically, these units become, right? Now I don't have molarity in the numerator anymore. 1 over seconds times molarity. These would be my units for a second order rate constant. And another way of writing that, as you may have seen, is if I have variables in denominator, I don't know if you've seen this in math class, but if I had 1 over x squared, did you know that you could write 1 over x squared as x to the minus second? It's the same thing. When I have a negative exponent for a variable, that means it's going to be placed into the denominator. So if I have 1 over seconds times molarity, this is the same thing as saying per second per molarity. These would be my units for second order rate constant. Now, your choices in one of your questions did not give you molarity, and this is where the fractions portion comes in. So I'm going to go to a separate page, and I have per seconds per molarity. This is this, and these are multiplied times each other. So this is the same thing as saying 1 over seconds times molarity. Okay, we just did that before. Remember, molarity is equal to moles over liters. So I'm going to plug this in to here. 1 over seconds times moles over liter. Now, I don't know if you know what to do if you have a fraction in the denominator. Remember, here's my numerator. And here's my denominator. If you have a fraction in the denominator, you multiply by the inverse, okay? So technically, what I'm going to eventually do is take the denominator and move it into the numerator, but I'm going to show you how I do that. This is the same thing as saying 1 over seconds times liters over moles. Right? I took this, if I divide 1 by that, my seconds is going to stay there, right? Because this is my fraction, and then I have a fraction in my denominator. So this is going to become this, right? So technically, I have 1 over, just put this on the side here because this is being multiplied by my denominator, 1 over moles over liter. It's like saying the inverse of that, or I could flip this and say 1 over moles over liter is the same thing as saying liters over mole. And if you don't know how to do that, that is dividing fractions. You remember the expression is multiplying by the inverse. Okay? So if I had 1 over moles over liter, that would equal 1 times liters over mole. Same thing. And so now if I go and do this math, or if I do this algebra, liters times 1 is liters, seconds times moles is seconds moles. And this is still my second order rate constant units. Okay? And so another way this has been written is liters times per seconds times per mole. This is the second order rate constant. And then just to quickly show you where the moles and liters, or we have negative here, before we had per seconds per molar, But remember, per molar is the same thing as saying it's opposite of moles per liter. Per molar is liters over mole. So that is where this came from. So I kind of just wanted to quickly show you what we do with fractions, what do I do with units when I have units in the denominator or fractional units, and how I switch that. Hopefully you could use this as a guide for the rest of the year, where you look at what do I do with units, how do I solve for units, and making sure that I keep units in my answers.